conference, and as Chris Justice was alluding to, this comes through a traditional string of conference that we have done in the past with Steve running in collaboration with the EOS NASA contingent for quite some time. And so the talk that I'm going to give today is more towards the satellite remote sensing side from an agency and interagency point of view, looking at outwards and looking at the users of satellite-derived information into to address key questions on earth science measurements and techniques. The group that I am co-leading with Gabriela Schaepman-Strub over at the University of Zurich has been on for quite some time. We're coming through about 15 years now, and our focus has been driven by the development of new land products, and throughout the years we have restructured our subgroup within CEOS, the CEOS working group on calibration validation to specifically target a suite of essential climate variables. And so when we're talking about satellite-derived products, what we're really trying to do is we're trying to meet the specifications from international bodies like the Global Climate Observing System, which are tasked to generate references, observations of key climate variables that are needed to address climate questions. And out of the current suite, we have this suite of products, and I'm happy to have seen throughout our sessions talks that have covered a wide range of algorithms and sensors that cover a lot of these products. These are our focus area colleagues. We usually have U.S., European, or Chinese or Asian contingents rotate through these positions, and we have a few of these folks present here. We have Crystal as our current surface radiation co-lead, which deals with all surface radiation data sets and derived products, including reflectance, BRDF, and reflectance, anisotropy, and albedo. We also have Luigi Sherry, who's our fire lead and who comes from the Heritage Modis team working on active fires in the area. And so we have Jose Sobrino looking at land surface temperature. This is actually one of our younger products in terms of its current addition to LPV, as well as land surface phenology, which is being added. A lot of the slides that we have here are just copied out from our last week's workshop that we had in Frascati, co-located with the ESA S-Spring Land Product and Validation Evolution workshop. And so the focus area leads, we met with them and we hacked out our differences and our goals for the next 3 years. In particular, what we do in terms of references is to foster and coordinate quantitative validation of higher level global land products. So we're not looking at the level ones or the calibration. That is done within the scope of the working group on CalVal, but we're particularly the brains that look at the level 3 products, your LAI, FPARs, and all these other all the biogeophysical parameters. And we're particularly interested in addressing these 4 core capabilities for validation. These are field sampling, scaling, techniques, accuracy reporting, and data and information exchange, all which have been mentioned in one way or the other throughout this session. And I'm very happy to see folks coming up with new techniques. We've looked at the LiDAR and how it can be used to derive biophysical parameters like LAI, and this is quite new. And so we are trying to develop an international or a consensus by which you can estimate products in situ and use that information to assess the quality and character of different global land products and the algorithms used to generate these essential climate variables. And so we are the face of our team. We hope to be, or at least we strive to be, the face of the international community, or your community, in the eyes of the CEOS and the group of Earth observations. And so we have a current website, and a lot of what we see here, if you're like, where can I get that? It's probably here. And we do routine maintenance, and we have a really nice support staff at Goddard that maintains this. You can see we're heavily advertising GV2M right here. I did my part. And again, when a lot of because of the heritage that we have with EOS, this whole started as a way for us to assess the accuracy of Modis line products. That's really where things got started. And the idea at the time was, we have these products, they're being stabilized, and we have to figure out a way to assess their maturity as we move along to the missions. And so at that time, we were product centric. We were not variable centric, and then that has really changed since then. We do not focus on a single algorithm from a specific product, but we look at the variable as it is, and it is independent of what methodology you use. You can come up with an LAI product that's driven by an empirical model or a highly deterministic model. For us, what matters is the variable, and how do you go about assessing it. But if you have an algorithm and you want to assess its quality globally, you have to have some kind of way to establish its maturity. And so these are the metrics that we use. And basically, you're just beefing up from one side to the other in terms of. And with lab products, the key part is, it's nice to, just look at a little plan and do your thing, and then, but you want to apply that globally, and you want to make sure that you have the global statistic to back up the efficiency of your algorithm. So again, we're very global in nature, and that means that you're assessing the accuracy of your product throughout different periods, seasonal periods, across a really globally representative sample. And as your product evolves, you're also reprocessing your data sets, improving the science. This whole feedback, it's a feedback process, and that's where you bring in stage 4. And just to be in perspective, we've been at it for 15 years, and some of them have barely achieved stage 3. Some products are still at stage 1 because they're extremely difficult to get, the right amount of measurements to truly come up with a global sample, namely like FBAR. FBAR is really difficult, and we barely have enough sites globally to actually truly, assess it continuously as it should be done to meet GCOS requirements. And so, what we have done is our strategy is to come up with these protocols, or what we call good practices for each of these variables. And we've begun to use, and the idea is to summarize all these techniques and all these processes that need to be done in order to be able to get a consensus, something that I can create a document that to turn Field Network and the NEON Network and our colleagues in JRC, everybody agrees that this is the LAI that we can get from a satellite, and these are the scaling techniques that we know work. And these are the scaling techniques that you can adopt, but they may get you all the way to stage 2, but they're not sufficient for stage 3. Those are the kind of things. And of course, if you really want true consensus, you know how difficult this is, because you have folks who are competing sometimes for, just the nature of science, in which you have a new method, and they have to set aside their differences and say, okay, well, let's deal with the issue of how we provide a common practice for this. And so that's why we always have to do this in terms of international structure. So just to give you a quick update in terms of 3 of the key variables that we've done, we have the FBAR validation concepts currently undergoing peer review. And so we do this out of an RSC paper, or we can actually come up with a standard protocol that falls under GEO terms, or even within an organization like NPL, in which we have something that has gone through significant review, and just like many of the ATBDs published by missions, we actually publish the feedback that we receive from our peer review panels, and the draft. It took us 4 years to get this one in particular, and this was actually an evolution in which we started with this idea that we needed these metrics, and both Fred and Sebastian Garrigues and a lot of folks really, provided the basis for understanding the basic concepts of intercomparison and site-level evaluation and measurement techniques. And so we have this. I should be actually advertising this more, but we have a printed version and an online version on our website for the LAI protocol. And again, we went at this thinking that we were going to cover everything, but we knew that it was just not going to happen. We really had to emphasize on a particular set of metrics and leave it as a living document, because that way, when you bring in, as we started finishing this, all these LiDAR, LAI retrievals started coming along. It's like, well, what do we do now? You have to, you just let it go. Just another co-lead will come in who's actually better at doing that than you, and they'll figure it out. And so we hope to have our new co-lead, Richard Fernandez, who was the main author, is stepping down after getting tired of having to deal with reviewers, and now we have one of his prodigies, actually from Baldacci-Strub, Oliver Sonnentag is going to be a new international co-lead for the biophysical group within LPV. And so there are still a to-do list in terms of things that we have to do for these products. I'll go through some of them just to give you a flavor. There are several ways to obtain optical reference data for LAI. You can use your track or your LAI retrievals, but what kind of plot level sampling do you need in order to truly scale up to a MODIS pixel or a MERIS pixel or a spot pixel? Those are kind of different questions relative to what a biogeophysical modeler would want to do at the plot level, or because it's. And so what we're trying to do is we're trying to establish the basis and just throwing it out there, because we don't want to overburden our reference networks who have been so helpful to us in terms of providing us with the key data sets that we need to evaluate these products. And so we provide these good practices, and it's not like you have to do this or else everything's going to break up. And the other thing is we have a process for upscaling data, and that means if you're applying a validation approach that relies on remote sensing data as one of your middle ground or in situ data sets, then you have to come up with a means to address the uncertainties within that product that you're now using as your anchor. And so that's a lot of work, again, driven by Sebastian and Jeff Morissette back in 2004, and in which we needed to do this in order to drive some of the intercomparison activities between products, and I'll show some examples for that. But enough about LAI. Let's look at other essential climate variables. As we see, if you want to go global, you need core sites, and we have the same technique for EOS. And for soil moisture, we're fortunate enough that we have the SMAP mission out of JPL, and their Caval leads are currently leading this activity, and because there's funding out there to actually get the necessary infrastructure to support a mission, we are at the right time to be able to gather these measurements. And so I'll be, we always have issues with being able to get good coverage in Africa, although that's pretty much for all essential climate variables. There's also a lot of infrastructure that was lost after the fall of the Berlin Wall, because the Soviets had a lot of infrastructure for soil moisture that we kind of know they're still measuring them, but we just don't have that international point of contact. And so it's key for us to be able to outreach other agencies across, and that's where the CIOS contingent comes in and helps us out. One of the key issues with soil moisture is that we still don't have a reference means of sampling soil moisture. It's everybody's doing it their own way. They have their own techniques there, and in particular they have their own set of hydro probes or Theta probes, and they use different high density sampling techniques. And until we actually get this fight over, it's gonna be very hard to come up with best practices. And so that's why we're trying to bring in the European contingent and the American contingent. Said, just fight it off and figure it out, because both of them could come up with very clean protocols for each other, but they won't agree on one that is the international consensus. And so that's where we come in and say, if that is the case, then let's establish a soil moisture test bed in which you just throw the whole thing. I mean, look at all those cables there. Yeah. It's crazy. And all this, it's the same way. You get 15 different ways to measure soil moisture. We still haven't figured out a way to cross-correlate them yet. And so these are the things that, in terms of the cutting edge, where we have to deal with site measurement techniques. And even if you're lucky and you're stuck, with land cover, there's a ton of different ways that you can actually do your sample design. And it's all dependent on what is your emphasis? Is it design versus model based? Is it focused on different climatological regions? And so a lot of emphasis has been put up for land cover to co-locate high-resolution imagery and address all these issues. I'm just going to keep moving forward. So I have a ton of ECVs, and we have a lot of material that came out of last week. Phenology validation. We saw some really interesting talks today about this, and I really applaud the work that Gautam has done out of the University of Southampton to get this up and going, because this one's the one where we have a lot of measurements and different techniques, and we have the willpower because we have a citizen science network who's willing and passionate about being able to provide the support structure, but it's a matter of getting organized. And one of the things that we can do is we can drive phenological metrics from a lot of different data sets. And so how do you actually come up with a means by which you say, okay, this is my core, this is the bare minimum you need to achieve state 1, and so forth. So what we have done, and we have this type 1, type 2 validation metrics in which you can have phenocam sites, and you can use that globally within 60 sites, and that would reach you to basically to a first order level of validation. And again, that is after you've actually go in, all those phenology folks have sat down and they actually figure out how to provide a consensus of what are phenology metrics. So just figuring that out, it's an issue in and of itself. But then, if you want type 2, then there's yet another degree of detail that you have to bring in terms of providing high resolution imagery and a sufficient temporal sample to capture those phenology metrics in a way that you can actually upscale the data all the way to landscape level scales. So that's sort of the rationale behind our validation, to also use flux towers and instrumentation to try to trace phenology directly to a biophysical parameter as opposed to just a proxy like NDVI. And so the other thing that we need to continue is like we're space agencies. We use this data also to drive algorithms. And sometimes it is very important for you to have that really good relationship with your reference network. And I'll give you an example for my team. I lead the VIIRS land validation effort for Chris Justice and our team at NASA. And we were given, we sort of established this collaboration with some China reference networks that were collecting land surface temperature. But we didn't put a lot of effort in terms of screening the data. And so when we use the current NOAA algorithm, which is actually a land cover dependent algorithm that drives the land surface temperature using regression coefficients, we installed that thing and suddenly we were off by 10 kelvins globally. And just to give you perspective, the threshold for land surface temperature is 2 kelvins. So we can actually fire the contractor if you're off by 3 kelvins to 4 kelvins, and we were off by 10 kelvins. And we were producing this globally. And so it underscores the significance of trusting your reference network and understanding the QA process. So you can't just separate QA from validation. It's one of our core things. The other thing is, as your products evolve, your missions need to evolve as well. And I think a lot of the operational agencies tend to want to keep it simple and just generate algorithms that have been tested and that are sufficient for data assimilation and weather forecasting models. But what they're missing is, once you evolve these algorithms, all that QA that happened to stabilize that algorithm, you're losing all that experience. And so, as an example, we have finally achieved a stage at which we have algorithms for land surface temperature that are land cover independent and they're emissivity dependent. And as a result, we're able to address all these issues in terms of being able to stabilize algorithm or even move away from all these thresholding that is necessary at the beginning of each mission in order to generate key data sets. With albedo, Crystal's been doing a lot of work to scaling the albedos, and we have ways to basically use geostatistical indicators to scale up all these sites. We use tower data, so in principle, by looking at the Landsat albedo, which Crystal's generated an algorithm for, you can actually look at the seasonal spatial dependency of albedo and try to relate it to that of the true footprint of a MODIS pixel or any other pixel. And so we've done this, and the nice thing is that we have indicators or scores that we can use to rank sites, and I emphasize we're ranking sites on the basis of albedo only. We're not going to Dennis's sites and say, sorry, your tower, this is not good. No, we're saying it's, we have a tower at 30 meters, and depending on the heterogeneity surrounding that tire, we assess its representativeness, and then we come up with a good practice approach to actually generate albedo data sets directly from point to the satellite data. Burn area, Luigi has been focusing on the intercomparison front, and it just underpins the challenge of being able to use intercomparisons to come up with a conclusion as to which products are stable. And it's quite a challenge, because as you can see here, it's, you know, some of these products are off by quite a bit, like this, the L3GRC, and I'm sorry, I don't even know about this product. I'm an albedo guy. But you still don't know which is true, and that underscores the significance of looking at intercomparisons. The same goes with LAI. I'll stop here since we have a very well-detailed assessment of these intercomparisons for LPV. And then obviously, to do this the right way, you have to have a sort of a means or an oracle at which everybody can put in reference data sets that have been screened by LPV users. And this is thanks to Fred and Marie. We have that basis. We have that capability. We tested it through the Olive portal, which is part of the COS catalog portal, and it's currently undergoing the development phase in order to add additional ECVs moving forward. So again, moving forward, we have all these space agencies increasingly investing in validation efforts, but we understand that the infrastructure necessary, it cannot just be driven by one agency. It has to be international in nature. And so our mission is to foster collaboration across products. We don't want just Luigi doing his thing and then Tom doing his thing. We want to be able for them to share the expertise that they learn in terms of upscaling parameters and everything. So these tools, these approaches, it's not easy when you have a grad student having to start over after another one leaves, because you lose all that talent as you move along. And then we want to support independent operational validation efforts, such as Olive's. To be able for me as a NASA point of contact to push subsets of all NASA-supported products to the Olive tool and be able to ingest in an objective manner all the evaluations and using the best practices that we have developed as part of our consensus with the community. So here are some of our agencies I want to thank, and in particular our prior, focus chair, Joanne Nightingale, who helped us out getting the LA printed out last week. That's all I have.
Miguel, thank you very much for this important work you presented here. I would suggest that any question the audience may have,